Very good morning to all of you. So I welcome you all for this engineering thermodynamics course. So the today's classroom discussion topic is the applications of steady flow energy equation. So we have to solve the numerical problems. So the motivation here is it is essential to solve the numerical problems on the various engineering devices to know the performance. So I'm expecting the outcome is every student should be in a position to solve the numerical problems based on the applications of the steady flow energy equation of the various engineering devices. So since the topic is restricted to the numerical problems, so let us solve one problem which is given in the earlier gate examination. So it is pertaining to the gas turbine application. In a gas turbine unit, the gases flow through the turbine is 15 kgs per second. That is, the mass flow rate is given as 15 kgs per second. And the power developed by the turbine is given as 1200 kilowatts. So here you are able to see the power developed is equal to 12,000 kilowatts. Enthalpy of the gases at the inlet and outlet, it is the H1 and H2 values are given. H1 is equal to 1260 and H2 is equal to 400. And the velocity of the gases at the inlet, so that is the C1 is equivalent to 50 and C2 is equivalent to 110 meters per second. So that is a very important one, that is you write down the given data first. So always whenever a problem is given to you, not only in engineering thermodynamics course, in any course, so first you write down the given data and plot the schematic diagram of the given problem. So based on this particular the data, now what he is asking, the rate at which heat is rejected to the turbine. So he is asking us to find out the delta Q. So delta Q value from the steady flow energy equation. And similarly, is also asking the second bit, the area of the inlet pipe, given that the specific volume of the gases at the inlet is 0.45 meter cube per kg. That is the volume of the gases at the inlet, small v, is equivalent to 0.45 meter cube per kg. That is asking now A1. A1 is equivalent to how much? That is at the inlet, what is the value of the area? So all these things will be calculated very comfortably from the steady flow energy equation, because how can you say that it is a steady flow energy equation means it's a gas turbine. So gas turbine is the example of the open systems. So that's why the steady flow energy equation only we have to apply. So now let us go to the steady flow energy equation here. So here already has given the C1 value as well as the C2 values. So the units are very important one. So substitute all the values. So we are able to get the Q is equivalent to 828 kilowatts. So whenever you are solving the problems, especially you concentrate on the units. So the units plays a vital important role. So the next one is the second parameter is the inlet area that can be calculated from the continuity equation. So we studied that continuity equation M is equivalent to CA by V. So we know M and from which you calculate A. So the area or the inlet we find it out as 0.135 square meters. So the coming to the second problem here. So in a steam plant, 1 kg of water per second is supplied to the boiler. So once again here, the engineering device given in the application is the boiler. So we studied that the steam boiler is also an example of the steady flow energy equation, that is open system. So the enthalpy and velocity of the water, so this he has given the various values. So here you write down the given data. According to this, you write down the given data. So just you use the steady flow energy equation, and he's asking us to find out the power developed by the turbine. So power is nothing but it's the W. So once you know the W, then only you can estimate the power. So first you from this steady flow energy equation, so by using all these assumptions, find out the work value and then you find out the power developed by the turbine. So the answer is 458.8 kilowatts. So like this, we can solve some numerical problems based on the applications of the steady flow energy equation. So in the next class, also we will solve some problems on the steady flow energy equations on some other engineering devices. I hope once you understand the concept of the steady flow energy equation and how to apply the assumptions And similarly, what is the function of that particular device, which one is to be calculated. Once you have the thorough knowledge on these issues, then absolutely there is not only an issue whenever you are solving the numerical problems on the steady flow energy equation. So thank you very much for attending this particular session. Thank you.